All right, 3.7. So we talked about dimensional analysis. We talked about our conversion of metrics, and now we're going to talk about standard conversions. So standard conversions are what we call our system. So if we are looking for 18 miles 2 inches, we know that 1 mile is 5,280 feet, thanks to remember the Titans. But we do know that 1 foot equals 12 inches. So with that being said, let's start with our 18 miles. We're going to try to get to inches. So we know that there are 5,280 feet. Remember, we're doing the same thing. So 1 mile equals 5,280 feet. Now, 1 foot equals 12 inches. So, we know miles cancel out, we know feet cancel out, so now we just do our math again. So we do 18 miles times 5,280 feet times 12 inches equals 1140480. And the easier way of doing this, putting in scientific notations, remember we only have 2, so we have to get it down to 2. So 1.4 or 1.140880 times 10 to the 1, 2, 3, 4, 5, 6, 6. But we have to get it down to 2. So really, it's going to be 1.1 because 4 cannot round. So 1.1 times 10 to the 6th inches. Look good? All right. Now, let's get to the next one. So we see that there is 8.45 times 10 to the 7th pounds for every gram. We see that there are 454 grams for every 1 pound. So that means we're taking 5 times 10 to the 7th pounds. We're trying to get to grams, so it's going to be 454 grams for every 1 pound. And our answer will be 8.54 times 10. I'm thinking that my calculator's not working for logs, doing anti-log, but it's okay. Times 10 to the 5th degree, but we can just multiply it by 10 times 10. That number doesn't look right at all. So let's do 5, 4, 1, 2, 3, 4, 5, 6, 7 times 454 equals 38363 times 10 to the 10th. But we have to get it down to 3 sig figs, so that means we have 3.84, because 6 rounds up, times 10 to the 10th power of grams. Does that make sense? Let's do one together on here. So we are going to do the multiple one. So let's do this one real quick. So we want to go from 70 miles per hour, and we want to get to kilometers per minute. So what we need to do here, we see that we want to get to kilometers, So we're going to go get the kilometers first. So there's 1 kilometer for every 0.6 miles. So that would get us to kilometers. So we have what we would want, but we want to get per minute. So we see that there's going to be for every 1 hour, there's 60 minutes. So that means we can get rid of our hours, we get rid of our miles. So then our kilometers are going to be over our minutes. So as we do that, we take our 70. Now we're going to divide it by 0.6 because we want to get to our kilometers. So we see that we're going 116.6 repeating kilometers per hour, but we want to see how fast we're going per minute. So really we're going to divide by our 60 minutes because there's 60 minutes in an hour. And that means we are going about 1.94 kilometers per minute. So that means, considering our sig figs, we're going about 2 kilometers per minute. Does that make sense? If we do our sig figs, because there's only 1 sig fig here, that means we're doing 2 kilometers per minute. Alright? Look good? Now you need to make sure you're doing your work on the rest of this. This is pretty standard, if you get what I mean. We use our combination of standard and metric for the United States, so you should be pretty used to this. Now, so good luck on your other 7. We will discuss next time that you're in class, and good luck.